Hey, my name's Brent. Welcome back to 49cc Scoot and the TMAX 500 service series. So in part 2 of this video series, I was doing a valve check and adjustment, and I think I messed up pretty big and bent a valve. So if you want all the details of that, please go back to that video. But for this video, I'm going to be removing the cylinder head and trying to find out if my valve is bent or not, and repairing it if it is. As you can see, this thing is already stripped down pretty far because of the other service stuff I was doing, and obviously because I was already trying to get into the valve. So if you want to see how all this stuff was removed, check out the previous videos. But for now, I'm going to start by just trying to remove the cylinder head. As you can see, I'm already as far as removing the cams, lifters, and the valve pads. So the next thing for me is going to be taking the exhaust off. Just in case anyone else was curious, the stock exhaust weighs almost 19 pounds. Service manual says to remove the thermostat housing, but I don't really see any reason to do that. It's barely taller than the intake portion, so I believe I should be able to just remove the hoses and the connections from around there, and it should be fine. Now I need to remove the head bolts, and these have to be removed in a certain order, which I'll go ahead and put on the screen. You probably can't really see the bolts on this side over here, but there's 2 bolts over there as well. And what you're supposed to do is loosen a half turn each time around. So 1, 2, 3, 4, 5, 6, 7, 8, a half turn. Then go back 1, 2, 3, 4, 5, 6, 7, 8, another half turn until they're all out of there. Now I'm going to try to remove the head, but before I do, you can see I've got a drain pan underneath of there. I'm sure at least some oil is going to come out. And I've got a towel over here so that when I take it out I can set it on something nice and soft instead of the concrete floor. And now I just need to disconnect my bungee cord that's holding my timing chain. Yeah, which is not bad. There should be a dowel here and on this stud. This one came out with the head. This one I'm going to remove. Now I'm going to hook my bungee cord back up to my timing chain. And then I'll stuff a rag in here just to make sure nothing falls in. And for now I'm just going to cover the rest with a rag, and then I'll probably put a drop cloth or something over this as well. Here's a look at the underside of the head, and this is the exhaust valve that was sitting deeper into the head. and you can see right there a mark across it like it came into contact with a piston. This one has no markings on it. These have, well, this has a faint marking. That has a little more of a marking. This one I can see is sitting up a little bit, which I'll show you in a second. On the intake side, you can actually see marks on those as well, but they seem to be faint. Probably I'm going to take all of these out and check them just to be safe. This is the valve that was sitting deeper in the head. I've got a flashlight shining into the exhaust port, and you can easily see the light through there and look into the port a little bit through that gap. I'm going to do a little bit of cleanup before I go any further, and I'm just going to use some carb cleaner. I'm going to spray that on, let that sit in the combustion chambers for a bit. While I'm letting that sit in there, I'll just see if I can get much off of the mating surface here. Now I'm going to switch over to a nylon brush and try to get some of that carbon out of the combustion chambers. I'm going to switch over to brass and see if I can do anything with these tough spots right between the exhaust valves. But generally, the softer the brush you use, the less you got to worry about damaging anything. The nylon shouldn't tear anything up. The brass, you could put scratch marks and things, but I'm not really worried in the combustion chamber itself. You can get a pretty good result with just some cheap, basic, softer material tools and a little bit of carb cleaner. And just to note, I tend to use carb cleaner for this kind of stuff because it's better at cutting down carbon residue than brake parts cleaner is. Whatever you choose to use, you'll want to do it in a well-ventilated area. Otherwise, you could kill brain cells and you end up doing stuff like bending valves and things. I'm going to try a quick leak test that Yamaha recommends in the service manual, and it's basically just to pour a clean solvent, so don't clean your barbecue grill, and then pour the leftovers into the ports and then see if it leaks out of the valves. Obviously, I know that at least one of my valves is going to leak, but I'm just curious to see what the others do. So, for a clean solvent, I've got a 2-stroke sitting around that had waited on a piston for about 3 months. So I've got some old gas. I'm just going to pour that in there and use that as my clean solvent. I'm going to start with the intake on the number 2 cylinder. That one's looking good. I don't see anything leaking out of it. Now the intake of the number 1 cylinder. It doesn't look like it's a whole lot, but it is seeping and it shouldn't be. For right now, all I'm going to do is make a note of this, which valve was seeping. Now I'm going to try the number 2 exhaust side. And the first try at this was a miserable fail. I tried to do it with the head position the same way, dumped gasoline all over my workbench, and then had to stop and clean all that up. It looks like maybe a very, very minor seep right around this edge here. But I'm going to go ahead and tilt the head down a little bit just to be sure that that gas is getting everywhere. It seems to be about as bad as it's going to get. Now for the number 1 cylinder exhaust valves. This is the one that you could clearly see all the light through. I'm kind of thinking this one's probably going to leak so bad you can't even tell what this one's doing, but let's find out. Why not? Yeah, I have no idea. This one drained it all out so fast that it ended up all over everything, so I couldn't tell you if this one seeps or not. I'm going to remove all of the valves, so of course that means all of the hardware is coming out along with it, the springs, retainers, etc. Whenever this stuff is removed, you want to make sure you know where it goes or where it went so you can put it back in the same place. I've already got all of my lifters and valve pads or shims in bags that are labeled, so I'm going to go ahead and continue and just put my valves etc. in there with those. And I showed you this in the valve adjustment video, but I go ahead and make a diagram on each bag just so I know exactly what I'm calling 1A, 1B, etc. And if you've never used one of these valve compressors, then basically you're just going to put one adapter is going to go up against the head of the valve, try to kind of center it on that. On the other side you've got another adapter, and that sits on top of the valve spring retainer. Then when you crank this down, it will compress the spring, and once it's down far enough, there are those two little keepers in there, and you can take something like a small magnet and fish those out. Then you release the tension or the pressure on this, and you can pull the spring and the valve and everything else out. In this case, I really don't have much room. This compressor is barely big enough to fit over the head, so it's a little tricky to get it off of there. There it goes. So this is the retainer. I've got a valve spring. Then I'm going to lift the head up, and I can push from the opposite side, and the valve will come out of there. You should see there's one more piece down on the bottom that you can grab with a magnet, hopefully. There we go. And also every valve is going to have a valve seal, and these are supposed to be replaced anytime that you remove the valve. So I'm just going to reach in there with some needle nose pliers, kind of twist and pull up, and hopefully that'll come off. Be easier if I could hold the head down, but I'm trying to hold a flashlight so you can see this. There we go. And once again, a reminder, everything is put into a bag labeled intake 2A, so I know exactly where it comes from. Now I've just got to do this again for 7 more valves. The rest of the valves are going to need a closer inspection, but this is number 1A, the one that I initially realized there was an issue with, and I can see from your house that that thing is bent. Now that the valves are out, I can see into the ports pretty well, and the exhaust has a decent amount of carbon buildup. Nothing really troubling, but while I've got them here, I'm going to go ahead and try to clean that area up. I'm going to do the exhaust and the intake. You just need to be really careful if you do any of this stuff. Right here around the edge basically of the port where it enters into the chamber, you can see these press-in valve seats, and the sealing surfaces in there, if you nick or scratch those, you can ruin those seats or possibly even ruin the entire head. You'd have to take the head to a machine shop and get them to do new seats. I've got a couple of these nylon brushes that I'll try to use around the valve seat areas just to be totally safe, but I've also got a whole bunch of brass wire wheels for a rotary tool that I'm probably going to do most of the work with. That just wore the nylon out pretty much immediately and didn't really do much cleanup to the seats, so I'm going to go ahead and switch over to brass. Now I've got all of the ports about as clean as I'm going to get them all the way through. If you're going to try anything like this and you decide to use cheap accessories like these cheap brass wire wheels, make sure you get plenty of them, because this is how many I've went through just for those small ports. And it looks like about 9 of them. I also want to clean inside of every one of the valve guides, because I'm going to try to take measurements of those, and I don't want any debris that could be in there to mess up my measurements. What I've got here is a straw cleaning brush, and you can find them in various sizes to work with pretty much any valve guides you would need to work with. You can even get something like a bore brush for rifle cleaning, and those will work for this kind of stuff. But I'm just going to spray some carburetor cleaner in each one of the guides, and then use this little brush to go through there. And this is a nylon or plastic kind of material. It's not something that's going to skin or scuff anything up. You don't want to use anything abrasive in there. And then I'll just spray through them one more time to finish. I want to measure the valve guides, and I'll also measure the valve stems, and with those two numbers I can figure out the clearance between the two and check them against the service manual specs. I don't really anticipate that there's anything wrong there, but it's not going to hurt to do it while it's apart. So the valve guides are very small inside, and you're not going to get them with any regular measuring methods with any accuracy. So what you need to do is get a set of small hole bore gauges, small hole gauges like this. And if you've used telescoping gauges before, they're basically the same idea, just a much smaller version of that. So they've got a little end in there, and as you screw this together, it will spread it apart. And you just set that, again, much like a telescoping gauge, until it feels like the right amount of resistance inside the bore of each one of these, and then take it out and measure it with a micrometer. Since I've just cleaned these and there's no lubrication in there, and I'm about to put something that's either steel or stainless steel in there, I really don't want it to scratch or create any more friction than I need to. So I've got an oil can with motor oil in it, and I'm just going to squirt a little bit into each one of the valve guides. Now I'm going to make sure that this is backed off enough that it'll fit in there, so I'll unscrew it a little bit, and then I'll insert this into one of the valve guides, put it in there a little way, and then start to screw it in until I feel mild resistance. It's a lot like doing a valve check, a valve clearance check, where you want to just feel a little bit of resistance. You don't want it to be really hanging up in there, and you don't want it to be loose. And try to move it kind of up and down while you do this. That feels about right to me, so I'll go ahead and pull that out. Be very careful if you're using this kind of gauge, because if I were to measure it this way, I get a much wider reading than if I turn it 90 degrees and measure it this way. But what I want to record is actually the widest reading, so you're going to want to do this multiple times and try to find the widest point. For a quick example, here's the wider side of it. Roughly 4 millimeters. And then if I turn it 90 degrees and then measure, much smaller, then I'm only getting less than 3 millimeters. Now I've just got to continue to do that for every one of the valve guides. And as you do them, write them down exactly where they came from. So
intake 1A, 1B, 2A, 2B, exhaust 1A, 1B, 2A, 2B.
now I need to measure all of my valve stems. And if you look at the valve stem, you can see this area here where it has some wear. That's the area where you want to measure. And you're just going to measure the diameter with a micrometer. So this one looks like 3.96 millimeters wherever I measure it. So I'm going to go ahead and write that down. Just like everything else, you got to write it down with exactly which valve it is. Now that I have all of my valve stem diameters as well as my valve guide inside diameters, it's very easy to find the clearance. All I do is subtract the guide ID from the valve, and that gives the clearance. So a really easy example here is intake valve 1B. The guide is 4 millimeters exactly, and the valve is 3.98. So that is 0.02 millimeters of clearance. So you can see I've calculated all of those. If you look at the service manual, they give you a spec as well as a limit, and they are different for intake and exhaust. But the spec is where they expect it to be, and limit is obviously the maximum clearance that you want to see. If you have more clearance than that, then you're going to need to swap out some parts. Luckily for me, it looks like everything here is well within the limits, and even my intake is pretty well centered in the spec. My exhaust sits a little bit to the wide side, but it's still very much fine for the limit. I want to do some runout checks on the valves, but before I do that, I'm going to clean them up, because even though there's not much carbon on these, I just want to be totally sure that it doesn't throw anything off. So what I'm going to try to do is chuck these in the lathe and then use my little brass wheels to clean up the area basically down here. You can tell where the carbon is. You don't want to clean all this area where it goes through the valve guide. You just want to clean basically the head. I'm going to put masking tape on the valve to try and protect the stems for when I chuck it up in the lathe. This looks pretty good, but I've got a little bit of general purpose degreaser on a paper towel, and I'm just going to run the lathe real quick and clean it up a bit more. Here's what the valve looks like after cleaning. Nothing fancy, just a good, simple cleaning. Everything feels very smooth. Now I'm going to check the runout as the service manual suggests on the valve stem. So they show setting the valve up with V-blocks or something similar, but the V-blocks are spread out and you're checking in the center of the valve between the V-blocks. That's kind of tough to do with such small valves unless you've got some really narrow V-blocks or some way to hold them. So what I did was I just took 2 V-blocks and I've clamped them down to a big thick piece of channel iron here. And I went ahead, I took a socket, a big impact socket, and put that in the V, and then I tapped that with a hammer, and then I carefully checked to make sure that everything was aligned here. So if you feel big ridges between the V blocks, then they're out of alignment and you want to keep trying to set them up. A lot of times you can just kind of tap with a hammer one way or the other and get them to sit in place. Once I did that, I just laid the valve in there. Again, I can't really measure between the V-blocks, so I just laid it in there, and I'm going to measure somewhere sort of central to the valve. I've got a dial indicator set up. You want to be very careful to set your dial indicator up so that it is perpendicular or at basically a 90-degree angle from your valve stem. And you can measure this in millimeters or inches. They say the maximum runout here is 0.04 millimeters or 0.0016 inches. So I've just got it set up for millimeters for now with a magnetic base on the indicator. And basically all I'm going to try to do is rotate my valve around gently. Obviously, I should mention when you put that in there, zero your indicator out where it sits on top of the valve. Anyway, I'm going to try to rotate my valve gently around and just see if my dial indicator changes or not. The dial indicator should put a little bit of tension down onto the valve stem, but you still got to be really careful not to pick it up or move it around when you're trying to rotate it. It's also a good idea to try and hold a finger or something against the back of the valve to keep it from going back and forth this way. So that looks really good. It's actually showing me zero change there. And you can move this around if you'd like and try to check in different spots just to be 100% sure. Now I'm going to use the mini lathe to make it easy to check runout against the face of the valve. So again, the valve is chucked into the mini lathe. I do have some masking tape around the stem of the valve to make sure I don't damage it. There would be a possibility that I could create runout that way, but I tried to wrap it pretty evenly. And then I've just got a dial indicator on the bed here, and it is as close as I can really get it to perpendicular to the valve or to parallel with the bed of the lathe. And then I can rotate the chuck and watch my indicator to see how much runout I've got this way. So if any valves were severely bent, I should see a lot of runout here. And I've got about 0.02 millimeters. Somewhere between a half and maybe up to a thousandth of an inch of runout. Which I believe for this sort of check should be okay. Now I've got my indicator set up at a 45-degree angle to the valve stem and valve. So it's right up against the 45-degree section on the valve head where it makes contact with the valve seat. And I'm going to try to do basically the same test that I just did for runout, except in this location. And again, it looks like about 0.02 millimeters, or about a half a thousandth of an inch. You can also do this check as well as the check against the valve face with just a set of V-blocks and your indicator, but this does make it a whole lot easier. What I would suggest is to get all of your valves cleaned, then do each test on every single valve, because the setup time for this kind of stuff is usually where most of your time is. So when you've got this all set up, take one valve out, swap the next valve in. Obviously just make sure you're keeping track of which valve you've got in there, record all your results, then when you get done with that, set it up how you need it for the next test, and do all the valves that way, etc. And that should save you a whole lot of time. I'm working through the valves and I'm not going to bore you with every one of them, but I will show you this valve that is obviously bent, just out of curiosity, so we can all see how bad it really is. I think I saw 1.68 flash by, yeah. So quite a bit of difference there. The other ones I'm getting 0.0 something millimeters, and this one is over 1.5 millimeters while measuring at the valve seat contact area. Here's a check against the face of the same valve. It looks like something like 1.08. And finally, here's the stem runout check. So you can see that checking the valve stem runout doesn't tell us a whole lot, because it's only about 0.01, even as badly as this valve is bent. I've checked all of the valves in 3 different ways. So again, I've checked the stem runout, the runout against the valve face, and the runout on the 45-degree machine section that meets up with the seat. So on all of them, the stem is really good. The worst runout is 0.01 millimeters on a badly bent valve, and everything else reads 0 runout on my dial indicator. When checking the valve head at the seat area as well as the face, most of the valves were between 0.02 and 0.04 millimeters of runout, which I believe to be fine. The one that was obviously bent was 1.68 millimeters of runout on the seat area and 1.08 millimeters of runout on the face, so no surprise there. The intake valve showing 0.1 millimeter of runout doesn't look bent to me. Even if I spin it on the lathe, I don't see that it's bent. However, they're not expensive enough that I want to take any chance, and again, if I trusted my own eyesight, I wouldn't have done all of these measurements. So I'm going to go ahead and order 1 intake valve and 1 exhaust valve. Now I'm going to try to get the exhaust studs out of here. I wouldn't really have to replace them, but at least one of them got gold up kind of bad because of all the rust on there when I removed the nuts. So if I can get them out of there, I'll go ahead and order replacements for those as well. I just got an email update about some of the parts that I ordered to do the cylinder head, and apparently now they initially estimated May 18th, today's May 6th. They initially estimated the 18th of this month, and now they're saying that I can't get parts, the intake valve and some washers that you're supposed to replace when you do the head, until July 2nd. So I'm going to see if I can drain the gas out of this tank, because apparently the TMAX isn't going anywhere anytime soon. Initially, I planned on waiting all the way into July until I got all the parts. Then I was going to put everything together and do one big episode about the cylinder head. But I think I'm going to go ahead and put this up. And maybe the next time you see me messing with a cylinder head, I'm considering doing a little bit of cleanup on the ports. And then hopefully I'll get my parts in and I can get it back together. But for now, I'm going to wrap this up. So as always, thank you for watching. If you enjoyed the video or found it helpful, please give it a like, share, and subscribe for more.